All right, compound probability. Talking about compound probability, the idea of compound probability is the idea that you have more than one probability event occurring. So go ahead and write that up at the top where it says compound. It's more than one activity. So maybe you might be flipping a coin and spinning a spinner, or rolling a die and flipping a coin, or flipping multiple coins, or randomly selecting a student from a list and flipping a coin. I mean, it's just all these different activities that could be happening. You have at least 2 or more activities that are occurring. Now, we're going to teach you how to build a tree diagram today so that you can see a layout of what the possible outcomes are. And we kind of did something a little similar to it a few days ago when we built that table of, if the green die and the red die land on different numbers, and we built all the different outcomes that could possibly happen with their sum. Something similar to that. It's not necessarily a tree diagram format, but that's essentially what we're doing today, is creating a tree diagram so we can list out all possible outcomes that would occur. Okay, now the all possible outcomes, that's what we call our sample space. That's that list. So when we made the list of the 2 dice, that was a sample space of 36 different outcomes that could possibly occur. Okay, now to build your tree diagrams, you have to separate them by different activities. So you need to first have an understanding of, how many different activities which would build your branches are there. So for example, number 1, we've got 3 coins. We have a penny, a nickel, and a dime. A penny, a nickel, and a dime. So that's 3 different activities that are going to be occurring. So you're going to want some colors. The colors are going to be helpful for you to be able to distinguish between the different activities, okay? So let's go ahead. We'll do penny with a blue. So I'm going to underline penny with blue. I'm going to underline my nickel with a green. And we'll do the dime with a pink. Okay? So the penny is the very first activity. That's the first thing that I'm going to flip. What are the 2 possible outcomes that a penny can land on, Shakayla? Heads or tails. So if I flip my penny, it could land on heads and it could land on tails. Those are the 2 possible outcomes that could occur. Now, my penny can land on heads, and my nickel can land on 2 options, and then my dime can land on 2 options, while the penny still stays landed on heads. Then the same thing, penny could land on tails, the dime and nickel each have their own options still. So the nickel, what options does it have? Heads or tails as well. So when I want to branch off, I'm going to branch to my next possible list of activities. This shows me what I can land on for the nickel. So I can have heads for the penny and heads for the nickel. But I could also have heads for the penny and tails for the nickel. Now the penny doesn't just have to land on heads, the penny could also land on tails. Now if the penny lands on tails, then the nickel could still land on heads, or the nickel could land on tails. Now that's just using those 2 coins, but I still have a 3rd coin, the dime. The dime also has how many options? 2. So let's say the penny lands on heads and the nickel lands on heads. What can the dime land on? It could land on heads, but it could also land on tails. So I now branched off even further for my 3rd activity. Now, what if the penny lands on heads and then the nickel lands on tails? Does that limit what the dime can do? No, the dime could still land on heads, or tails. And then repeating again. If the penny lands on tails and the nickel lands on heads, the dime could land on heads or tails. Okay, it's not limited by what its previous coins landed on. The penny could land on tails. The nickel could land on tails, but the dime could still land on heads or tails. This is called a tree diagram, where you start with an event or an activity, you branch to the next possible listing of outcomes, and then branch to the next possible listing of outcomes, depending on how many activities you have will determine how many branches out you have to create. Now, the sample space is compressing it all to say, okay, one possible outcome is that the penny could be this, the nickel could be this, the dime could be this. And then the next possible outcome, penny is this, nickel is this, dime is this. So if we look back here at our tree, your last set of branches will tell you how many total outcomes you've got. So if I count all of these HTs on my last branch, how many do I have in total? 8. So that means I should have 8 possible outcomes for my sample space. So I'm going to go ahead and create 8 spots. Oops, 5, 6, because I know I should have 8 total outcomes. Okay, let's start with the first possibility. What would be the first possibility of all 3 coins being? Huh? Heads, right? Heads, heads, and heads. That's one possibility, that all 3 of them are heads. What's the next possible listing that you would see here, Jimmy? Okay, you could do that, but there's actually one that's ahead of that. We could still have heads, and then what? Tails. We've done heads, heads, and heads, but we could still have heads, heads, and tails. Now notice I'm putting a check mark by these 2 to know, okay, I finished using this. Now since I've finished using both of these, what does that mean I'm now done with? The green head. So I'm going to put a check mark by that, knowing I'm done with the green head. Does that mean I'm done with this blue head? No. Why not? Because there's still a green tail, right? So now let's move on to that. We can do heads, tails, and heads. Heads, tails, heads. Am I done with the green tails? No, why not? You still have this last one right here. We could do heads, tails, and tails. Am I done with this? Yes. Am I done with the blue heads? Yes, because everything that's connected to that blue head is now completed. So who can go ahead and tell me what's the next possible outcome? Andy? Good. Tails, heads, heads. That's the next one. Camden? Okay, well, that's going to be our last one. Let's go in order. Let's make sure we go in order because we don't want to skip around. That's when you guys start getting messed up. Craig? Tails, heads, tails. So now I'm done with these 2 in the pink, which means I'm done with the green heads. Next one, Antoni. Tails, tails, heads. And then the last one, Camden, is tails, tails, tails. Okay, which means I'm now finished with all of them. I have all 8 written out as my sample space. based off of the sample space, I can now find these specific probabilities that it's wanting to know. So what is the total for the probability going to be here? 8, right? We know our total sample space is 8. So I know when I'm setting up my probability, it's always going to be out of 8. So I'm going to go ahead and write out of 8 for each one of these probabilities because there's 8 total in my sample space. So now let's just see which ones meet the need. Let's start with exactly 2 tails. So I'm going to put a star next to C, so that way I know when I'm looking back at my sample space, if I put a star next to it, it belonged to C. Does outcome 1 have exactly 2 tails? What about number 2, 3, 4? So I'm going to put a star by it. What about 5, 6? Yes, tails, heads, tails. It has exactly 2 tails, so I'm going to put a star by it. What about 7? Yes, tails, tails, heads, has exactly 2. And what about 8? No, it has 3. That's not exactly 2. So how many was I able to star? 3. So I have 3 out of 8. Can I simplify that? No. When in doubt, check it in your calculator. You can type the fraction 3 over 8 and hit enter to see if it simplifies, which it does not. So 3 over 8. If you wanted to convert that into a decimal, 3 divided by 8, or just hit your conversion button, and you would get 0.375. And as a percentage, that would be 37.5% because you just multiply that decimal by 100. No heads means you are not allowed to have heads in the outcome at all. I'm going to go ahead and put a triangle in orange right next to it. So I know anything that I put an orange triangle with means that it was belonging to problem D. How many outcomes up here have absolutely no heads in it? Which one? Number 8. So that's the only one that does not have any outcome of a heads. So that's one of them out of 8. Can that be simplified? No. As a decimal, that is 0.125. That's going to be equivalent to 12.5%. Probability of at least 2 heads. At least 2 heads. I'm going to go ahead and do a squiggly line in pink next to the E. At least 2 heads. Number 1? At least 2 heads? Yes. 2? 3? 4? No. 5? 6? 7? 8. How many of them? 4 out of 8. Can that be simplified? Yes. That simplifies to 1/2, which is 0.5, which is 50%. Any questions so far? Let's flip over to page 30. Doing the exact same idea, but instead of physical coins or spinners or dice, we're actually coming across a real world situation. We got an animal shelter. It has both male and female Labradors, and they come in colors yellow, brown, and chocolate. So we want to build a tree diagram, identify what the sample space is, and answer a few probability questions based off of that information. So the first thing that we have to understand is before we had coins, we knew the specific outcomes of those coins. Or if you have a die, you know the specific outcomes of that die. Here we don't have items, but we have categories. Reading the problem, who can tell me what are the 2 different categories that we have up here? That's one category. It's called gender, right? The gender, a choice of a gender. You've got 2 options for that category. What's the other category of things that you can choose from? Rumi? The colors. You can choose 3 different colors. yellow, brown, and chocolate. So you have two categories, a category of gender and a category of color. So you want to, again, make your tree. So let's go ahead and identify the gender as our blue. And that will be our first large portion of our tree. We have two options. They could be male dogs or they could be female dogs. Then in green, we'll do the options for colors, which is 3 branches coming off of the tree. So the male dog could be yellow, it could be brown, or it could be chocolate. But male is not the only option. You also have female as an option. And female could be yellow. The female could be brown. And the female could be chocolate. Do we have anything else? No. So that's it. We are done. Those represent the tree and then the branches that come off of it. So there's your tree diagram. So now based off of that, let's go ahead and identify our sample space. Who can raise their hand and tell me how many outcomes am I going to have in my sample space? Olivia? 6, because my last segment has 6 listed. So we're going to have 6 options or 6 total outcomes that we can place in here. So I'm going to go ahead and number 1, 2, 3, 4, 5, and 6. So what is my first possible outcome? Look up at the tree diagram. What is the first thing I'm going to write in my sample space for one of the outcomes? Jimmy? So male, yellow. Male, yellow. That's the first one. What's the second option, Ramla? MB. So male and brown. Male, brown. Third option, Safara? Male, chocolate. Landon, what's the fourth option? Female, yellow. Very good. So we have female, yellow. Craig? Female, brown. Good. And then the last option, Tegan? Female, chocolate. Okay, so there's our tree diagram. There's our sample space. These are all the possible outcomes that we could get. So now let's look at the very first question. The probability of female occurring. So again, what is my total? 6. So my total is going to be 6. Now out of these 6 outcomes, how many of them, I'm going to star it for C, how many of them were female? 3 of them, right? Option 4, option 5, and option 6 were female. So that's 3 out of 6. Can we simplify it to what? 1/2. So we get half of the options are going to be female, or 0.5, or 50%. Sorry, guys, I'm just trying to keep it up for those who just came in. Okay, probability for yellow. I'm going to put an orange triangle next to it. Again, the outcome is out of 6. How many outcomes up here have a yellow option? 2 of them. Option 1 And option 4. There's 2 options that have yellow, 2 over 6. Can we simplify? To 1/3, very good. And 1/3 is 0.3 repeated, or approximately 33%. Okay, now I'm going to zoom down a little bit. What about the probability of it being a female and yellow? Has to be female and yellow. 1. There's only one of them that's female and yellow, so it's 1/6. And 1/6 is going to come out to being about 0.16 repeated, the 6 repeats, which is approximately 16.7%. It's about 16.7%. And then the last question, not brown. Not brown. So I'm going to go ahead and put we'll do a green circle next to it. A green circle. So which of these options are not brown, Craig? There's 4 out of 6, right? Option 1 does not have a brown. Option 3 does not have a brown. Option 4 doesn't have a brown. Option 6 does not have a brown. So that's 4 options out of the 6. Can we simplify 4 6? To 2/3. Very good. And 2/3 is 0.6 repeated, which is approximately 66.7%. Okay, once you get that all written down, go ahead and flip over to page 31. We'll leave it up for about 15 seconds more, and then I'm gonna flip it myself. Okay. Flipping a coin, rolling a die. How many activities? 2. We got 2 activities here. So who can raise their hand and tell me what should be my large portion of my tree? What should I put here for the large portion? What do you think, Olivia? The coin, okay. And what are the options for the coin? Heads and tails. So we're going to go ahead and do the coin in blue. So we'll put the options heads, tails. Okay, so from there, branching out, how many options should I have branching out from each of them? 6. Why 6? Zoe, say it louder. Because there's 6 numbers on the die, and there's my second activity, rolling the die. So I should have 6 outcomes branching out from heads. That would be a 1, a 2, a 3, 4, 5, 6, and then the same thing again. 1, 2, 3, 4, 5, and 6. Am I done? There's more for the tree? No. I have answered all components of my activities. I have my coin represented, and I've got the die represented. So we're good. Let's go ahead and make the sample space. So based off of what we're seeing here, how many total outcomes is my sample space going to have? 12. 6 for the first and 6 for the second. So we have a total of 12 outcomes. So I'm going to go ahead and build up my sample space with 12 options. Okay, who can tell me what's the first possible outcome from the tree diagram? Antoni? Heads, 1. Next. Yep, heads 2. Miguel, what would be the next one after that? We did heads 1, heads 2. What's the next one? Heads 3. Francisco, what's the next one? We did heads 1, heads 2, heads 3, heads 4. Very good. Okay, Mariana, next one. Heads and 5. Good. And the next one, Mohammed? Heads 6. Hexel, what will be the next one? T1. Good. Tails 1. So we finished with all the outcomes that could be with the coin landing on heads. Now we move on to tails. So tails 1. Jesus? Tails 2. Good. Andy? Tails 3. Okay. Javari? Tails 4. Okay. Jossie? Tails 5. And Craig? Tails 6. Okay, so now all of these have been accounted for. We're done. There's our sample space. Okay, so let's start asking some questions, answering some probabilities based off of what we see up here for the sample space. So again, we've got 12 outcomes here. So I know every one of my probabilities is going to start off with the denominator being 12 because that's my total number of outcomes. So let's start with how many of the outcomes are heads and an even number. Heads and an even number. Shakayla? There's 3, right? Option number 2, 4, and 6 have heads and an even number. So there are 3 outcomes that satisfy those criteria. Can 3 twelfths be simplified? To what? 1/4. Very good. And what's 1/4 as a decimal? 0.25. Think of it as a quarter, right? And that is 25%. All right. Tails and greater than or equal to 5. Tails greater than or equal to 5. So am I going to look at options 1 through 6 at all? Why not? Because those are heads. None of those are going to satisfy it because they have heads. So we need to look at only the tail options and greater than or equal to 5. How many options is that going to be? 2. Very good. So we've got option 11 and option 12 are greater than or equal to 5 and tails. So that's 2 out of 12, which simplifies to 1/6. And that's approximately 0.16 repeated, or 16.7%. Okay, prime, talking about a prime number. So is there any limitation to heads or tails? No. So that means all of this is available for me to look at because it doesn't have a limitation at all put for heads or tails, which means I can choose heads or tails. It doesn't matter. Okay, so my only primary focus is to look for prime numbers. Remember, prime numbers are numbers that are only divisible by itself and 1. So that means it has exactly 2 factors, 1 and another number, which is typically itself. So is 1 a prime number? No. How many factors does 1 have? 1 factor, because itself is 1. 1 times 1, it only has 1 factor. So it's not a prime number. What about 2? Yes. And in fact, 2 is the only even prime number that we have. It's our only even prime number. All the rest of our even numbers are composites. 2 is a prime number, though. So let's go ahead. I'm going to do the squiggly line. So 2 satisfies. What about 3? 3 is a prime number. 3 is only divisible by 1 in itself. That's a prime number. 4? No. 5? Yes. 6? No. So we know 2, 3, and 5 are our primes. So then coming over to the tail section, 2, 3, and 5 will work for there. So how many options worked? 6. 6 out of 12, which is 1/2, 0.5, 50%. The last question, heads and a factor of 6. Factor means that you can multiply the number to equal 6. Multiply the number and it will equal 6. So if you multiply it by another value, it will come out to equaling 6. So are we going to look at options 7 through 12? No, because those are all tails. So we're only look here. Is 1 a factor of 6? Yeah, because 1 times 6 will give you 6. So that's going to work. So we'll put a circle, little circle next to the number 1. What about 2? Is that a factor of 6? Yeah, because 2 times 3. So that means 3 is also a factor of 6. Is 4? 5? 6? Yes. So how many options? 4, right? 1, 2, 3, 4 options. So 4/12, which is 1/3. Good. 0.3 repeated, or 33.3%. It might seem like we're doing a lot of practice on this because this is as easy as it seems right now to you. This is our number 1 missed concept on the interim and final exam. The number 1 missed concept. So we're trying to hit it hard because we would love for this to be the first year in the 6 years that we've had this school open and running that it's not our lowest performing concept. Okay? All right, let's take a look at the next example. For here, we're not going to be answering probability questions. We're just going to build the diagram. Arrangements. Arrangements is also a concept of a tree diagram, even though it does not have categories or several activities, but it does have branches because once you choose something, can you choose it again to arrange it? No. So it'd be like if I decide to put you guys in order for lining up. Once I put Miguel as the first person, he can't be chosen again. He's already chosen. He is now out of the running to be chosen as a second, third, or fourth place person. So it's the same thing here. If we're arranging letters or arranging colors or arranging people, once an option is chosen, you cannot choose that option again. But the first time that we're building it, do we have all options available? Yes. So if we're arranging the word or the letters from the word big, how many letters is going to be here in my first startup? 3. All 3 of them are going to be present. So I'll put B, I, G. Now, once I've chosen B, can I choose it again? So from there, how many options do I still have left? I and G. So that's how many? 2 options. I still have 2 options, I and G. If I choose I first, then do I still have 2 options? Yes, I still have the ability to choose B and G. If I were to choose G first, I still have 2 options, B and I. Now there's 3 letters that I need to put in order, right? If I choose B and then I choose I still have a third letter to choose. What's the third letter? G. But if I choose B and then I choose G, what's my third letter? I. If I choose I and then I choose B, what's my remaining letter? G. If I choose I and then I choose G, what's my remaining letter? B. If I choose G, then B, my remaining letter is I. If I choose G and then I, my remaining letter is B. Doing a tree diagram with arrangement, that's where people get most confused. But this is what the tree diagram would look like if you are arranging things in an order. So how many total options do I have? I have 6. So let's go ahead and build our sample space then. My first possible arrangement is to put the letters in order as B, I, G. What's my next possible arrangement? B, G, I. Very good. My third possible arrangement, I, B, G. The next one, I, G, B. Good. Fifth arrangement, G, B, I. And the last arrangement, G, I, B. I want you guys to do the exact same concept, but instead of letters, it's colors, blue, red, and green. Do the same idea. Build your tree diagram, create your sample space. Try that one on your own. Is there a sub over there today? All right, let's go over this real quickly. arranging the colors, blue, red, and green. So if we're talking about like maybe a rainbow, putting like, building a basic rainbow, putting them in order from, different colors. So we could start off, all three colors are available, blue, red, and green. But once I chose blue, then I only have red or green to choose from. If I chose red first, then I only had blue or green to choose from. And if I chose green, I only have blue or red to choose from. But then I still have to have a third color after that. So blue, red, green. Blue, green, good. Red, blue, red, green, green, blue, and green, red. Good job. So how many options? 6. So let's build that. Our first possible outcome, blue, red, green. Our second outcome, blue, green, red. Just ignore them, guys. Third option, red, blue, green. Fourth option, red, green, blue. Fifth option, green, blue, red. And sixth option, green, red, blue. All right. Your assignment tonight is on that page 33. It's on page 33. So I'm going to flip to it real quickly, okay, so you guys can see. You are going to have a tree diagram in which you're going to spin the spinner twice. So that means your first set is going to be what it could land on the first time, and your second set, the branches, is what could it land on the second time. So if I land on A, can I land on A again? Yeah, I'm spinning it, right? This isn't an arrangement. This is just spinning. So if I spin it, I could land on A, but I could land on A again, or I could land on B, or I could land on C. If I spin and land on B the first time, I could land on A, B, or C the second time, and so on and so forth. Then, after you're done doing that, they want to know what's the probability of getting at least one A. Then for here, you'll make your tree diagrams based off of the scenarios and your sample space. It's just those 5 questions. It's real quick and simple. Yes, sir. Due on Monday.